Sequences and summation notation, part 3. Adding terms of a sequence. Okay, so we looked at discussing sequences. Sequences can contain an infinite number of terms. 1 term, 2 term, 3 terms, 6 terms, 100 terms. They just go on forever. When we want to start adding up some of those terms, maybe not all of them, when we want to look at adding up some of those terms, then that's what we're looking at with a partial sum. We want to add up part of the terms. S1 would add up the first term. There's nothing to add to the first term, so it's just A1. But if I want partial sum 2, I add up the first 2 terms. Partial sum 3, add up the 3 terms. Partial sum 4, add up the 4 terms, and I can keep going in this same pattern. Okay, find the first 6 partial sums, S1, S2, S3, S4, S5, S6, as given. Okay, so let's see how we can get partial sums. Okay, so as we had said, S1 would be just adding up that first term, nothing to add, so we would just get 1. S2 would be adding these 2 terms, 1 plus 3, that would give us 4. S3 would be adding up the first 3 terms, 1 plus 3 is 4, plus 5 would give us a 9. S4, we would be adding up the 4 terms, so we'd have 1 plus 3, which is 4, plus 5 is 9. 9 and 7 would give us 16. Now we're ready for the first 5, because they want us to give the first 6 partial sums. So we're going to need S5 and S6. Okay, so let's see. What would be that 5th term? We got 1, 3, 5, 7, 9. 1, 3, 5, 7, 9, 11. So for S5, we're adding in 9 if we sum these first 5 terms. 1 plus 3 plus 5 plus 7 plus 9 is going to give us 25. Then for the 6 terms, we're going to add in 11. 25 and 11 is going to give us 36. And those are the first 6 partial sums. Okay, S1. S1 is going to be 1/3. S2, first 2, is going to be 1/3 plus 1/9. Now we're adding fractions, so in order to add fractions, we're going to need a common denominator to add these two together. Okay, so we'll multiply this one by 3/3, so 3/9 plus 1/9 is going to give us 4/9. Okay, if we keep moving in this pattern, S3 is going to give us 1/3 plus 1/9 plus, what we're trying to do is add these 3 terms together. 3 cubed is going to be 27, so that's going to be 1/27. And now we can see that maybe getting a common denominator isn't too hard, but the calculator is going to help us out. Here we would, to get that common denominator of 27, multiply by 9/9. Here we would multiply by 3/3. And so we've got that common denominator of 27. What happens with the numerator? We've got 9 plus 3 plus 1. 9 and 3 is 12 plus 1. That would give us 13/27. Okay, so then our next step would be to add up all 4 of these. Okay, and so we can see that at this point we're going to just go ahead and let the calculator, help us out with some of this. Okay, so let's grab the calculator. and we're going to plug in. I want to check these. I want to show you how we can check these, and then we can move on to the next one just to make sure that we know that we're getting things correct. To work on problem 39, we're going to need a formula to generate this. And if we looked at a previous example, the formula that we came up with was 2n minus 1. So we said a sub n was 2n minus 1. Okay, so let's put that in our expression. So we've got 2n, which it uses x, so that's okay. 2n minus 1, variables x, we're going to go 1 through 6, since they wanted the first 6 partial sums. So I'm going to go through and do a paste. What this is going to do is just show us that our formula is working. 1, 3, 5, 7, 9. Now I want to start adding these up. Okay, so we're going to go back to second list, but instead of going into OPS for the sequence command, we're going to go one over into the math menu and get the sum command. What we want to do is we want to sum the sequence of numbers. Okay, so we're going to hit sum. We can either go back into sequence and re-enter our information, or in this calculator I can just grab it here, and let's say I want to add up not the first 6, let's add up the first 4. If I add up the first 4, that's where we got 16. So let's see if we were right or not. Yay, we were right. Second enter brings up the next one. We want to add up, say, the first 6. That's what we got here with the 36. And so here we're just saying, okay, now we know how to sum sequences in our calculator. It works. Let's see how we can get this one done. Now notice that we do need, however, we do need a formula for this. And so let's see if we could get a formula. We have a sub n is equal to, we notice that 1 is always on top, and then what's on bottom is 3 to the n power. Remember, the values that you plug in for n are 3 to the first, and then becomes 3 to the second. N was our domain, and in part 1, we knew that the domain for sequences is always 1, 2, 3, 4, 5, however many we want to plug in. Okay, so let's get our formula in. We're going to go second list operations. Option number 5, here's where we can put in an expression. 1 divided by 3 raised to the x power. X is the variable. We're going to start at 1. Let's go to 2. That way we can check this 4/9. Let's look at adding up the first 2 terms of the sequence. Okay, so here's the sequence, and we know that these are all fractions. So I'm going to go ahead and turn on answer in fraction. So here's what we were adding up, the 1/3 and the 1/9. Second list, math menu, option 5 for sum. We're going to sum this sequence. Answer in fraction. I'm going to put a parenthesis here to wrap up. I've got a parenthesis for the sum, I got a parenthesis for the sequence, and I want my answer in fraction. Okay, if we did our math right, we should get 4/9, and there's our 4/9. Okay, second enter brings up our command. We're going to change this to a 3. There's our 13/27, so we know that we did that one correctly. Then we can go to the fourth partial sum. We're adding up these 4 numbers. That's a partial sum of 4 terms of our sequence. Then we can go to the fifth partial sum. and finally the sixth partial sum. And there's our three answers. Let's go on to our